8.4 binomial probability. A binomial experiment, or Bernoulli trial, is where you've got an experiment and you repeat it over and over again. There are two possible outcomes, either success or failure. So what's going to happen is they're going to give you a probability. So let's say the probability is 0.25, let's say. All right, so whatever is happening in this experiment, the probability is 0.25. Then what you would need to know is the probability of that not happening is 0.75. And that's going to happen in every single problem. You're going to have a probability of success and a probability of not success or failure. The trials are independent, so that means probability of success is the same for each trial. So they've got a formula, and this formula looks a lot scarier than it is, but with X successes out of N trials, you're going to have NCX times that probability to the X power, and that's just however many you're looking at, however many successes there are, times 1 minus P, or not P, to the N minus X. So this looks really scary, but it's not that bad at all, and it's going to repeat itself over and over and over again. You'll get the format here when we see an example. Example 1, a single six-sided die is rolled 10 times. Find the probability of rolling a 4 exactly 3 times. So this is a binomial experiment because we're repeating the same experiment over and over again. In fact, 10 times. So looking at the variables in the problem, 10 times, that's n. And we want to roll a 4, okay? We're rolling a six-sided die. That's the experiment, but we're looking to specifically roll a 4. And so the probability of rolling a 4 on a six-sided die is 1 out of 6. And 3 times, that's our X. That's our specific number that we're looking for. That's how many successes there are. Okay? So we need to use those numbers and plug them into the formula. So N is 10. And then we're going to have C, and X is 3. And then the probability of success is 1/6. And we're going to have that success 3 times. So that means we're rolling a 4 3 times. And so if you think about what that means is if you roll the 4 3 times, then that means you roll something else 7 times. So that something else would have a probability of 5/6. And we would see 7 of those. Okay, so that's what we have to enter into our calculator. So let's do that. We have 10, choose 3, times 1/6 to the 3rd, times 5/6 to the 7th. Okay, I just type it all in like that. You get 0.1550. I like 4 decimal places, so I'm going to say that probability is about 0.1550. Part B, find the probability of rolling a 4 at least 9 times. So here we've got a little bit different problem because it says at least 9, and you have to think about what that means. At least 9 specifically means 9 or 10. Now, we've learned in this chapter that the or means we're going to add 2 scenarios. So we're going to have something plus something. So we're going to do the formula twice, once for 9, once for 10. We're going to add them together. So the numbers are still the same. N is still 10, and P is still 1/6 over here. So we're going to do 10, choose 9, times the probability 1/6. That's your success 9 times. And your failure is 5/6, and that's going to happen 1 time. All right, it's got to add up to 10 because there's 10 experiments there, or 10 repetitions of the experiment. Okay, plus we're going to do 10, choose 10, and it's going to have a success 10 times, and so that means there'd be a failure 0 times. Okay, so oops, not an NPR, it's an NCR. Okay, so you've got that number. That means times 10 to the negative 7th. So that means move your decimal place 7 times to the left. That's going to put 6 zeros over here. So let's just write down that. That's a decimal point. 1, 2, 3, 4, 5, 6. What was it? 8269. Okay. Plus. And then over here, one thing you can do that might save you some time is if you remember that something to the 0 power is equal to 1, you can kind of save some time. And also, if you know that 10 choose 10 is going to be 1, we wouldn't really have to type those in on our calculator. Right? 10 choose 10. Is 1. And 5/6 to the 0 is also 1. So really all I need then is that 1/6 to the 10th power. 1.6538 times 10 to the negative 8th. So we're going to have 7 zeros. Yeah, move it 8 times, so you're going to have 7 zeros and then 16538. Okay. We add those two numbers together, and we get a really small number. Add them together, and I get, what is that, 7 zeros, 8434. Very, very small probability, but look at what we're dealing with. You find the probability that you roll a 4 9 times or 10 times. Yeah, that's probably not going to happen, so that's why it's such a low probability.